You know, in today's world, having a solid wireless connection isn't just nice to have, it's everything. But have you ever noticed that the second you walk into a building, that perfect signal can just completely disappear? Let's talk about why that happens, and more importantly, how the pros actually fix it.
I mean, it's a story we all know, right? You've got 5 bars outside, you're walking and talking, you step through one doorway, and suddenly, you're in a total dead zone. So what is going on?
Well, it's because a whopping 80% of all our mobile traffic happens inside. Think about that. The vast majority of our data is trying to fight its way through a maze of modern building materials.
And the very things we use to make our buildings strong and efficient, stuff like concrete, steel, even that fancy energy-saving glass, they are the sworn enemies of a good wireless signal. They literally block, absorb, and bounce around the radio waves we rely on.
So you can see why just, sticking an antenna on a wall and hoping for the best, well, it's just not going to cut it. To beat these physical barriers, you need professional tools. You need a plan. You have to actually engineer the solution. And that's exactly where iBwave design comes into the picture. For professionals in this field, this software is the go-to standard around the world for planning and designing any kind of indoor wireless network. And the Level 1 certification, that's your first step to becoming a master. Okay, so the whole process starts with a really cool and critical idea. You have to create a perfect digital copy of the physical space first. Think of it like building a digital twin of the building before you even think about installing a single piece of real hardware.
Getting this foundation right is absolutely everything. First, you import the floor plans, and these can be anything, PDFs, CAD files, whatever you've got. Then you set the scale, and this is so important because being off by even a little bit can mess up all your predictions later. And finally, you trace the walls and tell the software exactly what they're made of so it knows how every single surface is going to affect the signal.
And you can see that whole transformation right here. It's amazing. You go from a flat 2D drawing to a fully interactive 3D model. And this isn't just for looks, okay? It's a scientifically accurate digital blueprint that actually understands how radio waves are going to travel through that specific building.
So once your digital twin of the building is ready to go, the next step is to actually start building the wireless network right on top of it. This is where you get to place all your antennas, your cables, and all the other fun stuff.
And you're not just using some generic icons here. Oh no, you have this massive, constantly updated database with, get this, over 29,000 real-world parts from all the major manufacturers right at your fingertips.
This means you can just find and drag and drop the exact antenna or the exact cable you're planning to use in the real installation. Every single part has its real-world performance data baked right into the software, which gives you incredible accuracy.
Now, as you're connecting all these parts together into what's called a distributed antenna system, or DAS, the software is basically your expert partner looking over your shoulder. You see that little debug message list down there? It's constantly checking your work for errors, flagging things like mismatched parts or overloaded equipment to make sure your design will actually work.
And this, right here, brings us to what is arguably the most powerful part of this whole thing. Instead of spending a ton of money to install a system just to find out if it works, you can simulate its performance with a single click.
The result of that simulation is something called an RF heat map. It's basically a super intuitive, color-coded map that shows you exactly how your network is predicted to perform right down to every single square inch of the floor plan. And here it is. This is the magic. The green and blue areas, that's where your signal is great. The red areas, those are your weak spots, your potential dead zones. A designer can see this, virtually nudge an antenna a few feet to the left, run the prediction again, and watch this map change in real time. You can perfect the entire network before anyone even steps on site. It's a total game changer. Now, when you're looking at these heat maps, you're analyzing a few key things. Signal strength, or RSIE, tells you just how powerful the signal is. But signal-to-noise ratio, or SNR, is often even more critical. That tells you how clear the signal is from all the background interference. You really need both to be good for a great connection. All right, so having a great design is awesome, but it's really just the beginning. The final phase is all about creating the right documents to get it built, bringing in data from the field, and, of course, getting your skills certified. Now, this is brilliant. Engineers out in the field can use the iBwave mobile app on a tablet to snap photos or make notes like, hey, watch out for this giant pipe right here. And all that info instantly syncs right into the main design file.
This is huge for preventing expensive mistakes and redesigns because it connects the person at the desk with the person on site.
And what about all the paperwork? Well, when the design is done, the software basically does it for you. It automatically generates all the reports you could possibly need. A complete bill of materials, equipment lists, cost details, you name it. It saves countless hours of tedious work and gives you a totally professional package to hand off to the client.
So, where does this all lead? Earning your Level 1 certification isn't just about learning a piece of software. It's about proving to the entire industry that you have the skills to tackle a complex indoor wireless problem and deliver a network that works perfectly right from day one.
At the end of the day, it's about the difference between just hoping you'll get a good signal and actually engineering one. It's about replacing all the guesswork with proven precision. So really, the only question left is, are you ready to start